In this lecture, we will going to learn about the operators. We have very different types of operators like arithmetic operators, comparison operators, logical, bitwise, identity. And in the end of this lecture, you will going to understand every type of operators. So let's just start our lecture 4. Let's start with the arithmetic operators. So what are arithmetic operators? You can know with the name only that operators used to perform mathematical operations. So if we want to perform mathematical operations like addition, summation, subtraction, division, we use arithmetic operators. For example, if I give you an example, if A is 5 and B is, let's say, 25. So if I want to print the sum of these two numbers, then I will print A and I will use an arithmetic operator which is plus, and I will run this command, so I got the summation. Similarly, minus, multiplication. There are many arithmetic operators like plus, minus, multiplication, division, modulo, exponential, and floor. So these are all the arithmetic operators we use: addition, summation, multiplication, division, modulo. So let's come, you know about all these four, like division, summation, and others. But let's talk about these three. First of all, modulo. Modulo basically is used to find out when we do the division, there are two results. One is quotient and one is remainder. If we want remainder in our output, we use modulo. Okay, so for example, B modulo A. So if you see, B is our 25, A is 5, and if I do the modulo of these two numbers, then it will give us the output, the remainder of these two. So what will be the remainder? It will be 0. See, the output will become 0. And for quotient, we use division. The quotient will be 5, 5.0. So basically, this is the property you can say for a division. Like it always gives us the floating value. If we use integers both sides of the division symbol, then it always gives us the floating value. But if you want an integer value, like you don't want decimal value, then we use this symbol. This is called a floor division. So if I use this, then I will got an integer value. So if you want an integer, you will use floor, and if you want decimal in division, then you will use normal division symbol. And one thing in division, Like if you give any negative value, let's first take that if I take 3 here, which is not divisible with 25, so then also it removes the point value. But if I do a normal division, we got something value like this, 8.3333. But in floor value, it removes all the point and values after the point. And if my answer is here, the one important concept about floor division is the value will be always greater but less than the value will always be greater but less than the value we will get in the answer. For example, we assume we have values of a and b something. Okay, if the quotient, if the normal division gives the, if its output is 3.9, let's assume a have b some value which give the output of 3.9. So if we do the floor division, its output will be 3. Can you understand what is this? Whatever the value we have, it always removes, it do not round off it. It always keep the value to the value which it had before the point. If I have here 4.0, then value will be 4. It just only remove the point value and nothing else will be changed. Okay, so I hope you can understand this. So now, one more concept. If a value is minus 3, so again let's assume if we have b as a negative number and the output, let's assume the output is minus 3.9. So what will be the value in floor division? Can you answer it? The value will be minus 4. Why? Because the floor value will always give that value which is less than this, less than the value which come in the floor division. The value will always be in a short trick. I can say that the value of floor division will be always the left side of the value which come in normal division. And you can also say that it is always be less than the value in the normal division. Okay. So floor basically what do? Division of operand where result is the quotient. in which digits after the decimal point are removed. Okay, so division of the operand where result is the quotient in which digits after the decimal points are removed. And what about this symbol? It is an exponential symbol. Basically, exponential means if I write print 2, then exponential symbol 3, then it means 2 to the power of 3 and its result will be 8. Because if we multiply 2, 2 into 2 into 2. So this is 2 to the power of 3. Its result will be 8. So this is the meaning of exponential symbol. So these all are the arithmetic operators. Now we move towards comparison operators. Now what are comparison operators? So basically comparison operators, as you can see from the name comparison, these operators are used to compare. Used to compare two values, and they always return result in true or false. Comparison operator are used to compare two values. They always return result in true or false. Means their result will always be either be true or false. So basically this is also a data type which the result in which we are returning true or false. That data type is Boolean. Let me just show you an example. So first, there are many comparison operators. First is equal to, less than, greater than, less than equal to, greater than equal to, and not equal to. So yeah, these are the comparison operators. And let me tell you what they do. First, equal to equal to. If I use equal to, so a single equal to is used to assign values. And if I want to compare A and B, if I want to know that are the values of A and B are same, then I will write A equal to B. So here, when I write this, basically I am comparing, I am asking that is the value of A and B is equal to 0. So yes, they are equal, and the result of this print statement will be true. So yeah, you can see that the result of this is true. So if I assign this value to C, and then I print type of the data type of C. So here you can see the data type of C. So basically what is stored in C? A equal to B, whose value is true. So I told you that true and false are the Boolean data types. So here you can see that bool is written, which basically means Boolean. Similarly, you can do like uh, if I write here not equal to, so what will be the result here? This is basically a symbol of not equal to, means telling that A and B are not equal to each other. But we can see that A is 4, B is 4, they are equal. So this statement become, this expression become false. So you can see the result that the false showing, because A and B are equal, but we are saying that A and B are not equal. So here I will write, it shows that two values are equal, and not equal to is values are not equal. And greater than basically means it basically says, as you know, I think, I assume that the left value is less than value at right. If I give an example, if I here write 7 and here I do this, so I am saying here that A is less than B. So is A less than B? A is 4, B is 7. So yes, A is less than B. So its result will be true. Greater than, okay, and less than equal to means that the left value, let me copy this, left value is less than or equal to value at right, equal to the value at right. So if I give an example, if I put here equal to, then it is saying that A is less than equal to B. So if I check that A is 4, B is 7, 4 is less than 7. But here also I have written equal to. So here you can see that there is in this symbol there is two conditions, that A is less than B or A is equal to B. If the condition true from both to condition is true from both to any of the condition is true. From both condition, in any of the one become true, either less than or equal to, then the result will be true. Here 4 is not equal to 7, but yes, it is less than 7. So the answer of this statement will be true. If I here put 7, then yes, 7 is not less than 7, but 7 is equal to 7. So again, it will be true. But if I change here, now it is saying A is less than equal to B, means 8 is less than equal to 7. Now we will check first condition, is 8 less than 7? No. Then second one, is 8 equal to 7? No. So both condition are becoming false. So its result will be false. Similarly for greater than equal to, the value at right. The left value is greater than or equal to the right. So here if I do greater than equal to sign, then this, here it will check is greater than or equal to B. 8 is not equal to 7, but yes, 8 is greater than 7. So its result will be true. So yeah, this is all about the comparison operators, and they always give you result in form of true or false, which is a data type of Boolean data type. So this is all about comparison operators. So we have covered arithmetic and comparison. Now we will come towards bitwise operators. So what are bitwise operators? Bitwise operator basically, if let if I want to work, if I have values and I want to work with the bits of those values. If I've let's take two values. If I take these two values and I want to work on the bits of these values, means how the 6 is written in binary form, because binary form basically written in bits, right? 0 and 1. So how the 6 is written? So 6 is written 1, 1, 0. So this is how the 6 is written in binary format. If you don't know how I find out that, I have written first 1, 2, 4, then I have written 1, 1, 0 according to it. Then if you don't know, then I will tell you that if you want to, if you want to write any value in a bits, so what you have to do, you just need to write down the values first to the power of 0. I hope you know what is 2 to the power of 0. 2 to the power of 1, then 2 to the power of 2, then 2 to the power of 3. Let's first take this example. If I want to write a value 1 in the form of in binary form, then here what is the value of 2 to the power of 1, which is 1. So because I want 1, here 2 to the power 1 is 2, here 2 to the power 2 is 4, 2 to the power 3 is 8. So here I have seen that 2 to the power 0 is 1 and I also want 1, so I put 1 here. I got 1, but here 2 to the power 1 is 2. I don't want 2, I want only 1. So I will put 0 here. Basically here what is I am doing? I am including 2 to the power 0 by doing 1, and you can say that I am rejecting 2 to the power 1, which is value of 2, but I don't want to, I want 1, so I put 0. Then again 0, then again here 0. So this is how we write 1 in binary form. Now suppose if I want to write 2, how will I write 2? So you can see that 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, but I want 2, so I will put 1 under this, and elsewhere I will write 0, 0, 0. So this is how you write 2 in the binary format. What if I want to write 5? If I want to write 5. So here it 2 to the power 3 is 8, 2 to the power 2 is 4. Here it is 2, here it is 1. We can't find value 5. So in this case, what we can do is, let me just tell you that you will if they here it is 8, 8 is greater than 5. So we will reject this, because if I if I do addition with 8, if I add 1 also in 8, it become 9. So it is we are just going far away from the value 5. So basically I will choose 4 and 1, and elsewhere I will write 0. Here also 0. So here what I have done, I can't able to find the value 5 here. So I will do the submission, like which number I will add so that I can find the number 5. So we can't add anything to 8. So we will choose number less than 8. So here we have 4. So yes, 4 is less than 5, that we can use it to make it 5. Then I go to 2. 2 to the power 1 is 2. But if I add 4 plus 2, it will become 6, but we want 5. Then we don't 2 to the power 1. We go to more smaller value. Here 2 to the power 0 is 1. So yes, we use 4 plus 1, which is 5. You can find out, you can take any combination, you can't able to find 5, but only these two. 2 plus 1 is 3, 3 plus 4 7, and 8 we can't use because it is greater than 5. So okay, I hope you can understand what I'm trying to say. Now I just say we want 10. If we take 10, we want 10. So how will I find? First, go to the greatest value, 8, 2 to the power 3. So we will use it. Now, 2 to the power 2, which is 4. So 8 plus 4 is 12, but we want 10, so we will reject this. Now 8 plus 2, yes, this is 10. And we got 10, so we also reject this. So this is how we write 10 in binary form. So if you want very more greater values, like if you want 20, then get we can't able to write 20 in using these values. We can't use only these values. We have to get to the more values like 2 to the power 4. So what is 2 to the power 4? 16. So if I see that 2 to the power is 16 and 16 plus 4 is our 20. So we will do this. We will reject this. 1, 0, 0. Yeah. So this is how we write 20 as a binary form. If we come to more greater values, then we will do 2 to the power of 5. So we will use this also if we need it. So this is how we write the number in binary form. So I hope you understand. So this is how, so if I come to bitwise operator, we are going to operate with the bits of these values like a equal to 6, b equal to 7. So we are going to operate to the bits of these values. So what are the bitwise operators? Operators take one or two operands, take one or two operands and operate on them bit by bit. Okay, so this is I have told that they work on the bits of those operands. Here I have operands 6 and 7, which is stored in A and B. So what are the bitwise operators? First we have left shift, then right shift, then AND operator, then we have OR operator, then we have NOT operator. So let's talk about all of these one by one. So first of all, what is left shift? So as this name says left shift, it basically shift the number to the left. What does this mean? Like if I have a variable a and I store, if I print 6 left shift 1. So here I have done 6 left shift 1. So what does this mean? Basically, I am shifting the bits of 6 towards the left side by 1. What does this mean? See here, I have written a binary format of 6, 4, 2, 1, 4 plus 2 is 6. So this is how we write 6 in binary format 1, 1, 0. So here I have to shift these values 1, 1, 0 towards left by 1. Like I will shift this 1 towards left by 1. How will I shift this? Like this 1. I have shifted towards left. Then again I move to a second value. Then again I will shift towards it, shift it towards the left. Now, so first, let's talk about what we have talked about till now. We have to shift the every bit value of 6. So we have bit value of 6, 4, 2, 1. We use 1, 1, 0. So what we have to do, we have to shift all the bit values of 6 towards left by one place, by 1. So below 4, we have this one. So we have shifted towards left by 1. And below 2, we have this one. So we have shifted this value towards left by 1. And also we have 1. Below we have 0. So also we have shifted towards left by 1. So when we do this, here it becomes 0 and this will be removed. So now we got our final value. When we see that the value below 1 got empty, we just put 0. And now what you will see here, that 100. So here we are seeing that it become 4. If we see the binary value, it become 4. So now if I will print this 6 left shift 1. So let's see what will be its value. Its value is 12. Mm, oh yeah, I have done a mistake. Sorry for that. Um, Basically, so yeah, here it will be 8, right? Because we have, so as I have told you that we have shifted the all the values by 1 towards the left. So below 4 we have 1. Before that, well, let me just tell you what we have before it. 8, 2 to the power 3, 2 to the power 2, 2 to the power 1 into to the power 0. So yes, 2 to the power is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8. Before that we have 1, 1 and 0. This is the binary form of 6. 4 plus 2 is 6. So we have to shift towards left by one place. So I will shift this. So I have shifted by one places towards left. And here it got empty, so I will write here 0. So now what will it become? It is 8. This is 4. This is 0, 0. So 8 plus 4. 8 plus 4. We will not include these. What will be its value? 12. And if I run this command, that we have written here, print statement 6 left shift 1. So what will become our output? 12. And here also we got 12. So this is how left shift work. Similar to the right shift, we have done right shift by the value of 1 for 6. Now what we will do, right shift. Here we will do right shift by place of 1. We will move this first tab, make it 6. So this is now become 6, right? 110, 4 plus 2 plus 0, which is 6. So we have what we have to do, we have to do right shift by 1. So here this 0 come outwards by 1. This 1 below 2 to the power 1. 2 to the power 1 is 2, which means it come below 2 to the power 0, which is 1, and 2 to the power 2, 1 will come below 2 to the power 2, 1 come below 2 to the power 1, 1. So here also, if I do this, if you see here, this is 6. So what we have to do, we have to do right shift by 1. We will do shift towards right. So what we have to do, right shift. This. What we have done here, right shift, and before 4 it becomes 0. So now we have done the right shift and we will remove this 0. Now what will it become? 2, 1. And what is 2 plus 1? 3. So that means the value of 6 right shift 1 will be 3. See, our output become 3 here. So I hope you can now understand. If you have any doubt, then please write in the comment section. And there is also a short method For the right shift, there is a formula actually from which you can calculate what will the value. So for the formula of left shift, we use left value multiply by 2 to the power of, we can use exponential 2 to the power of the right value. So this is the formula. If I give you simple, like for example, if I want to do by the same example, 6 left shift, just say 2, then the bit will move towards left by the place of 2, like 1 2. So what will be that value? So the output will be 6 multiply with 2 with the to the power of 2. So it will be equals to, what will be the answer? 6 divided by 4. So it will be 3 by 2. It will be around, it will be I think 1. So if I do the left shift with 2, what will be the answer? It comes 24. Oh yeah, it is multiplication, right? So 4 6 are 24. So yeah, correct. With the same right shift, it also has a formula but is different from the right shift, the left shift. Here it will be division, not multiplication. Everything else will remain same. For example, if I take the same example but right shift with 2, then the output will be 6 divided by 2 to the power of 2. And what will be the answer? If I do here right shift 1, yes. So if you see, the answer will be 1.5 something, but here the decimal will be removed and we got 1. Okay, so this is left shift and right shift. Now we have AND operator. AND operator basically, if you have studied about the AND operator, and or not, it is also one more, XOR. So what about the AND operator? Basically, it means we work with the bits. If I do here AND, we got 2. Why? See, we have a binary form of 6 is 1, 1 0. So this is 6. And if I write 2 in binary form, what will it be? Okay, this is 2. So if you know that right AND operator basically means if we have uh, if we have 0 in, we will compare bits by the position. Like here we have 0, also we have 0, so we will compare. So if you know, I hope you know this, how the AND is worth, like 0 0 0 and 0 gives 0, 0 and 1 gives also 0, 0, 1 and 0 gives also 0, and 1 and 1 gives 1. So this is how AND operator works. If we use 0 and 0, it gives 0. 0 and 1 gives 0, 1 and 0 gives 0, and 1 and 1 gives us 1. So right here also we will compare these two values first, then middle ones, then the last ones. So here, what will be the value of 0 and 0? So you can see here 0 and 0 is 0. So here it becomes 0. Here, here we will compare 1 and 1. Here 1 and 1 gives us 1. And here 0 and 1. You can see here 0 and 1 give us also 0. So now you can see our final answer. What is our final answer? Our final answer is this, 0 1 0. And if you find out, if you see this is a binary form, if we convert into our number, what will be the value? It will be 2. So here also if I print 6 and 2, the output is, here also you can see 2. So this is how AND operator works. So when from the two values of 0, what can be the definition? If it has then output will be 0. So you can observe that 0 and 0 is 0, 0, 1 is also 0, 1, 0 is also 1. But when the both 1 become 1, then the output will become 1. So you can see if at least 1, 0 is present to the left side with the AND operator. If 1 is 0, then answer is automatically becoming 0. If 1 is only in that case when both the operands in the AND operator is 1. So that's what I have written here. Now if we come towards the OR operator. So it also works like AND. What is it? In AND. If I take this similar, if I talk about OR here. So here the symbol of OR is this straight line. Here it is straight line. And in OR, 0 and 0 is 0. 0 and 1 is 1. 1 and 0 is 1. And 1 is also 1. So you can see by observing it, the definition will become if it has 1 at least. Ones from both operands. Then outputs will be 1. So here you can see the definition. If the from both the operands, if one operand is 1, then the output would always be 1. But if both operand are 0, then only the output will be 0. So it kind of reverse of the AND operator. And if I do here AND, sorry, OR, then what will be the our final answer? So you can see here we have to compare now 0 and 0. What is 0 and 0 is our 0. What is 1 and 1 is our 1. What is 0 and 1 is our 1. So if I combine these values 4, 2 and 1. What did I say? 4, 2 and 1. Then 4 plus 2 is 6. So our final answer will be 6. What does it mean? It's mean that if we do the OR operator for 6 and 2, then the answer will be 6. If I run this command print 6 or 2, answer output is coming 6. So this is how OR operator works. Now if I come towards the NOT operator is a I should turn out this to the capital letter. So what is not? It is a unary operator. What does the meaning of unary operator? Basically, it means that we use only one value with a not operator. Like here, we are using two values with or, we are using two values with and. So similarly, like we use only one value. Urinary operator means it used with only one value. Example 6. So what will be its output? So how this not works? So basically it converts 1 into 0 and 1 into 1. What does that mean? Basically, if I have value 0, then it will change it to 1. And if I had value 1, then it will change it to 0. Like if I have 0, 0, 1, 0, then what will be the value? We will go towards the each value. So here 0 will become 1, 1 will become 0, 0 become 1. So if you convert this into convert this binary form into number, here it is 2 to the power 0, which is 1. 2 to the power 1 is 2, which becomes 0, so we will not add 2. We will add 4. So 4 plus 1 is 5. Here we have taken example of 6. How 6 is written? 1, 1, 1, 0. So we will do 0 to 1 and 1 to 0. So 0, 0, 1. So means your not of 6 will become 1. Output will be here 1. If I do same this not of 6, what will be the output? -7. So yeah, so this is not the -1. This will be -7. Why? Because there is formula we use in not operator, which is the formula is minus of x plus 1. So if we are using not of 6, then we will put 6 on X and we will calculate this. So this become minus 7. So the output will be minus 7. Okay, so this is how NOT operator works. Basically, in NOT operator, the system is not perform on just 3 bits. It takes infinite number of bits. Like here, it is not only 001. It is 0, 0, 0, 0, 0, 0, 0. There are infinite number of zeros. And when those infinite number of zeros are converted into 1, so that means if I see, so if you see this, this is how we write 6, 1, 1, 0. 4 plus 2 plus 0 is 6. Now here we have converted this into not operator. We have converted 0 to 1 and 1 to 0. But in left side also, there is also 0 present. Then it will be converted to 1. And all those zeros in front of these are converted to 1. And there are infinite number of 1. So basically in binary format, 1 represents minus. It represents minus sign. So that's why here 1, 0, 0, 1, it means 7. And the 1 before this represents minus 1. This is the rule of the binary form. Okay. So now we will come towards our last binary bitwise operator, which is XOR. XOR is basically, if I tell you the definition, let's first do a code. If I do XOR of 8 with 2, if I tell you the rules of XOR, what are the rules of XOR? If we have 0 XOR 0, then the result is 0. 0 XOR 1 is 1. 0 XOR 1 XOR 0 is 1. And 1 XOR 1 is 0. So basically here what you can observe that when the two operands will become equal to each other, then our values become 0. And if they are different, like 0 and 1, 1, 0, both operands are different, then our result is becoming 1. So this is how XOR operator works. If two operands are equal to each other, then outputs will be 0. Hence 1. If the operands are equal, then the output will be 0, else it will be 1. So if I do 8 XOR 2, it will become 10. The bitwise of 8, bits of 8 and 2 will compare together and perform the XOR operation, and then the final answer will be 10. So these are all the XOR operators, sorry, bitwise operators that work on bits. So these are the operators we have covered today. So if you have any doubt left or something is not clear, you can write down in the comment. And if you want to give any feedback, please write down the comments. So thank you for this is enough for today. Thank you.